Good evening, everyone. Good evening, guys.
Good evening, ma'am.
Good evening, ma'am.
Good evening, Kanna. So, last class, we have revised atomic structure and we have seen few questions from the chapter, right? In this session, also, we're going to discuss a few problems from atomic structure. Okay. But before getting into the problems, let us have a quick recap. What is the one-Lee formula which is involved in photoelectric effect? What is the one-Lee formula which we'll be discussing in photoelectric effect? I think we have discussed the formula also, I guess. What was the formula? H nu is equal to Tatvatika?
Yes, ma'am. H nu is equal to H nu naught plus kinetic energy, that is half mv square.
Exactly. So H nu is equal to half mv square. Guys, am I audible?
Yes, ma'am.
Yes, ma'am.
Okay. Okay. Guys, is my screen visible?
Yes, ma'am.
Is my screen visible?
Yes, madam.
Fine. So the formula was H nu is equal to H nu naught plus G. Okay, okay, sir. Thank you. Okay. So what is H nu naught? What is H nu naught? Basically, that is the binding energy between the nucleus and the valence electron, right? What is the another term for this threshold energy or binding energy? There is another term for this threshold energy, right? What is that? Work
It is work.
function. Okay. So h nu is the energy of the incident light, and yes, and h nu naught is the threshold energy, or it is also called as work function plus kinetic energy. And formula of kinetic energy is half mv square. That's it. Okay. What is Pauli's exclusion principle? What is Pauli's exclusion principle? No two electrons in an atom can have same set of quantum number. That is Pauli's exclusion principle, right? Okay. What is half pass principle? 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 Whenever you are filling the electron in an atom, you have to fill the electron from lower energy level to higher energy level. That is half pass principle, right? Okay. What is the mathematical expression for Heisenberg's uncertainty principle? What is the mathematical expression for Heisenberg's uncertainty principle? Delta x into uncertainty in position, uncertainty in momentum, which is greater than or equal to h by 4 pi. This is the mathematical expression of Heisenberg's uncertainty principle, right? Instead of this momentum, we can write it as P represents linear momentum. Linear momentum can also be expressed as mass into velocity. So, uncertainty in position into mass into uncertainty in velocity, which is greater than or equal to h by 4 pi. Is it? Is there any other term, or is there any other mathematical expression for Heisenberg's uncertainty principle? Delta E into delta T, which is greater than or equal to h by 4 pi. So we cannot measure energy and time of the microscopic particle simultaneously. Right? Okay. How many orbitals will be there in fourth shell? How many orbitals will be there in fourth shell? I think we have revised all those concepts in the last class, right? How many orbitals will be there in fourth shell? Last class we have calculated manually, and also we came for the formula to calculate the orbitals, right? What is the formula to calculate number of orbitals? Yes, it is n square. So here n is 4. So 4 square is 16. Tatvatika was right. So maximum number of electrons that can be accommodated in fourth shell is maximum. How many electrons we can accommodate in fourth shell? Fourth shell will have 16 orbitals, and each orbital can accommodate of 2 electrons, right? So maximum how many electrons we can accommodate in fourth shell? 16 into 2, right? Fine. What is Lyman series? What is Lyman series? Or what is the value of n1 in Lyman series? What is the value of n1 in Lyman series? It is 1, right? Guys, what happened to you? Why you guys are very quiet? Okay, shall we move on to questions then? Shall we move on to problems? Okay.
Yes.
Okay, the first question is Heisenberg's uncertainty principle is not valid for which of the following? Heisenberg's uncertainty principle is not valid for which of the following? Moving electron, motor car, stationary particle. Option 4 is both 2 and 3.
Ma'am, both 2 and 3, ma'am.
Very good. Why, Kanna? Basically, Heisenberg's uncertainty principle is applicable for moving microscopic particle. Okay, so here electron is a microscopic particle. So Heisenberg's principle is applicable to moving electron, but not to the motor car or the stationary particle. Okay, so answer is option 4. Geethan's answer is also right. Fine. Next question. An atom of chromium whose atomic number is 24 loses 2 electrons. How many unpaired electrons shall be present in chromium 2 plus? They've given you the atomic number of chromium itself, and they're asking us to remove 2 electrons from chromium, and they're asking us to calculate how many unpaired electrons will be there in chromium 2 plus. Very easy question. Okay, Tatvatika's answer is option. Number of electron is 4. Okay. So, atomic number of chromium is 24. And what is the electronic configuration of chromium? Argon. Argon.
3d5 and 4s1.
4s1, 3d5. Actually, the expected exactly. Expected configuration is argon 4s2 and 3d4, but this is the wrong one because we know that half filled and completely filled configuration will make the atom more stable, right? Here d4 configuration is partially filled configuration, which is unstable. But if we move one electron from 4s to 3d, then this makes a half filled configuration, and half filled configuration are more stable. So the original configuration of chromium is argon 4s1, 3d5. So now we have to remove 2 electrons from 4s and then from 3d, right? So we have to remove 2 electrons. One electron I'm going to remove it from 4s, another electron from 3d. So the configuration is 3d4. So in 3d subshell we'll be having 5 orbitals in which we have 4 electrons. According to Hund's rule, we have to fill 4 electrons like this. So there are 4 unpaired electrons. So answer is option 1. Okay. So we'll move on to next question. Here, a transition metal has a configuration of argon 3d5 in its plus 3 oxidation state. Its atomic number is dash. A transition metal X has a configuration of argon 3d5 in its plus 3 oxidation state. Its atomic number is dash. They gave us the configuration of some cation, and they're asking us to calculate the atomic number of that element. So Tatvatika's answer is second option. Okay. Divya, what is your answer, Kana? Geetan? Varsha? Okay, Tatatika will
Ma'am,
check.
B.
So, there is some. Yes, Geetan?
Option
Okay,
2.
Divya's answer is also 26. We'll check. So, there is an element. Okay, so there is an element called X and its oxidation status +3 and its electronic configuration is 5. So originally there should be 3 more electrons, right? So the original configuration would be argon 4s2 and 3d6. So this is the configuration of element X, right? 14 electrons plus 2 plus 6, 8 electrons. So the atomic number must be 26. Next question. What is the wavelength of a particle of mass 6.62 into 10 power minus 29 gram moving with a velocity of 10 power 3 meter per second? So they're asking us to calculate the wavelength, and we are provided with the mass and velocity. So which formula we have to use to calculate the wavelength? We are provided with mass and velocity. So which formula we have to use to calculate the wavelength?
De
We know
Broglie's
the
wavelength.
formula to calculate. Very good, very good. De Broglie's wavelength. So what is the formula? Lambda is equal to h by mv. So m is the mass of the particle and v is the velocity of the particle in which particle is moving, right? Or if this can also be written as h by mc. If the particle is moving with the velocity of light, then the formula can be written as h by mc, or h by mass into velocity can be written as momentum. So all these three formulas can be used to calculate de Broglie wavelength. Here the particle is moving with the velocity of 10 power 3 meter per second. So I'm going to use this formula. So lambda is equal to, what is the value of h? It is Planck's constant basically. So 6.626 into 10 to the power of minus 34. In the denominator we have weight, mass. So anyways we going to express that in kilogram. So I should write the Planck's constant in terms of kilogram. So kilogram meter squared second part. What is the unit of Planck's constant in terms of kilogram? Kilogram meter squared second power minus 1 divided by, what is the mass of the particle? 6.62 into 10 power minus 29, and I'm going to express this mass in kilogram. So into 10 power minus 3 kilogram, and what is the velocity? 10 power 3 meter per second. So what are all the common terms and units? Second inverse and second inverse will get cancelled out. Kilogram will get cancelled out. 1 meter and 1 meter will get cancelled out. So we'll get the value in terms of meter. So 6.62 will get cancelled out. So simplify all this 10 powers and please come up with the answer. Definitely answer is not option A and B. So what is the answer?
Option C, ma'am.
Option C. Yes, Divya was right. So answer is option C. Okay. Next question. The electronic configuration of hydride ion is dash. What is the electronic configuration of hydride ion? What is hydride ion? What is hydrogen? It is basically H, right? And what is the electronic configuration of hydrogen? It is 1s1, right? So hydrogen ion is nothing but H minus 1. So there is an extra electron in hydrogen. So what is the configuration of hydride ion? It is 1s2. So the configuration is 1s2. So the answer is option C. Right. Okay. The total number of orbitals in fifth energy level is how many orbitals are there in fifth energy level? Yes, Tatvatika's answer was right. The answer is 25. Basically, formula to calculate number of orbitals in a given shell is n square. Here, the value of n is 5. So, 5 square is 25. That's it. Next question. Okay. The atomic number of an element is 17. The number of orbitals containing electron pairs in its valency shell is dash. Option A 3, option B 4, option C 6, and option D 8. First, write the electronic configuration and check for the orbitals which contains electron pairs. But the key point is we have to check the orbitals of valency shell. Varsha, what is the answer? Okay. Okay, Divya's answer is option A. Tatvatika's answer is also option A. Okay, we'll check. Geetan, Varshini. Okay, let us write the electronic configuration of this element. So the configuration is 1s2, 2s2, 2p6, 3s2, 3p5. Which is the valency shell? Third shell. So 3s can be written as like this. And 3p subshell can be written as p subshell got 3 orbitals, right? So this is 3p. So 3s electron, 3s subshell, 3s orbital got 5 electrons. 1, 2, 3. So how many orbital pairs? 1, 2, and 3. So answer is option A. Is that clear? Fine. We'll move on to next question. The radius of hydrogen atom is 0.53 angstrom. And they're asking us to calculate the radius of lithium 2 ion. They're asking us to calculate the radius of lithium 2 ion. Okay. So what is the formula to calculate the radius? Okay, Varshini's answer is option A. Tatvatika's answer is option B. Geetan's answer is also option B. Divya is also she's telling option B, right? Okay, fine. We'll check. Okay, what is the formula to calculate the radius? Basically, lithium 2 plus is a single electron system, so we can use the Bohr's formula, right? So what is the formula? Rn is equal to 0.529 n square divided by Z angstrom. So 0.529. Since the element is lithium, atomic number of lithium is 3. And what is the value of N? What is N? The shell in which electron is present. In lithium 2 plus, there is only one electron, and there is no mention about the shell in which electron is present. So basically, that electron should be its ground state. And if the electron is present in ground state, then the value of N is 1. So it is 1 square. So 0.529 divided by 3 angstrom. So the answer is option 2. Fine. So what is the answer? It is option 2, right? 0.17 angstrom and not option A. Is that clear? Shall we move on to next question? Okay. If the energy of a photon is given by 3.03 into 10 power minus 19 joule, then wavelength of the photon is dash. They are asking us to calculate the wavelength of the photon, and we are provided with the value of energy. So we know the value of energy, and they are asking us to calculate the wavelength. And we have to know the relationship between energy and the wavelength, right? What is the formula? E is equal to h nu. So frequency can be written as C by lambda, right? And they're asking us to calculate the lambda. So lambda is equal to hc by E. So what is the value of Planck's constant? 6.626 into 10 to the power of minus 34 joule second. And what is the value of C, which is velocity of light? 3 into 10 power 8 meter per second divided by what is the value of energy? 3.03 into 10 power minus 19 joule. So this joule and this joule will get cancelled out. Second and second inverse will get cancelled out. 3.03 can be written as 3, and this 3 and this 3 will get cancelled out. So please simplify all those 10 powers and please tell me the answer for lambda. Divya's answer and Tatvatika's answer is option C. Okay, right. So the answer is option C. So we have to express the wavelength in terms of nanometer. So 10 powers should be like 10 power minus 9, right? Fine. So shall we move on to next question? Shall we? Okay. The following quantum numbers are possible for how many orbitals? N is equal to 3, L is equal to 2, and M is equal to plus 2. The following quantum numbers are possible for how many orbitals? Divya's answer is option A. Varshini, what is your answer? Khalai, Geetan. Geetan's answer is also option A. Okay, Anu's answer. Okay, everybody is telling option A. Okay, let us check. So, n is equal to 3. So, this is third shell, right? In third shell, how many subshells will be there? 3 subshells. What are they? L is equal to 0, L is equal to 1, and L is equal to 2. They have mentioned the azimuthal quantum number is 2. So this one. In L is equal to 2 subshell, how many orbitals will be there? 5 orbitals will be there. 1, 2, 3, 4, and 5. And what is the magnetic quantum number of all those 5 orbitals? Minus 2, minus 1, 0, plus 1, plus 2. And they have mentioned the magnetic quantum number as just plus 2. Plus 2, right? So they have mentioned only one orbital, right? So answer is option 1. So n is equal to 3, L is equal to 1, and m is equal to plus 2. This quantum number is possible for only one orbital. Okay. So next question. The value of Planck's constant is 6.63 into 10 power minus 37 joule seconds. The velocity of light is 3 into 10 power 8 meter per second. Which value is closest to the wavelength in nanometers of a quantum of light with frequency 8 into 10 power 15 second inverse? So they're asking us to calculate the wavelength, and we are provided with the frequency. So we have to know the relationship between wavelength and frequency. What is the relationship between wavelength and frequency? Nu is equal to C by lambda. Here we have to calculate the value of lambda. So lambda is equal to C by nu. So C is 3 into 10 power 8 meter per second, and the frequency is 8 into 10 power 15 second inverse. So second inverse and second inverse will get cancelled out. So you have to simplify this and you have to find the value of lambda in terms of nanometer. Divya's answer is option B. Divya, what is the exact value you got for wavelength?
3.75 into 10.
Okay, 3.75 into 10. Okay. 3.75 into 10 meter, right? 10 into 10, I mean, into 10 power minus 10 meter, right? 3.75 into 10 into 10 power minus 9 meter. Am I right, Divya? So it is
Yes, ma'am.
nanometer. Fine. So this can also be written as 37.5 nanometer. Approximately 37 can be written as 40 nanometer, right? So option 4 is 4 into 10. Basically it is 40. So answer is option D. Shall we move on to next question? Next question is, an electron collides with a hydrogen atom in its ground state and excited it to a state of n is equal to 3. How much energy was given to the hydrogen atom in this inelastic collision? So initially electron was in the ground state, right? N is equal to 1. And now this electron is getting excited to n is equal to 3. So we have to find how much energy should be supplied on this electron to get excited from first state to third state. So basically we have to find the energy gap between n is equal to 1 and n is equal to 3. So what is delta E, which is change in energy? E3 minus E1. And what is the value of E3, or what is the energy of the electron? If the electron is present in third shell, we know the formula, right? Minus 13.6 Z square divided by N square minus 13.6 Z square divided by N square. So here the value of N is 3. So this is 3 square. And here the value of n is 1, so 1 square. So 3 square is 9, 1 square is 1. We have to take the common terms out, and we have to substitute the value of Z. Since they are talking about hydrogen atom, the atomic number of hydrogen is 1. So substitute the value of Z and simplify this. We know here the unit is in electron volt. So please simplify and tell me the answer of delta E. But Tatvatika, we don't have such option, right?
No, ma'am. Actually, it is the value of E3.
Okay, fine.
Sorry, ma'am. Actually, I done by substituting the value directly, ma'am. Like 13.6 minus 0.84.
Okay. Okay, now simplify and let me know the answer, Tatvatika.
Ma'am, it is nearly 12.7, ma'am. 7 electron volt.
Okay. So Divya's answer is also 12 point something, right? Right, Divya?
Yes, ma'am.
So which means we have to supply 12 electron volt of energy on the electron to excite this electron from first state to third state. So answer is option A. Is that clear? Shall we move on to next question? Geetan, do you have any doubt, Kanna? Fine. Given that the mass of electron is 9.11 into 10 power minus 31 kilogram, Planck's constant is 6.626 into 10 to the power of minus 34 joule seconds. The uncertainty involved in the measurement of velocity with a distance of 0.1 angstrom. So here they are asking us to calculate the uncertainty in velocity, which means delta V. So obviously the question is from Heisenberg's uncertainty principle. We know the mathematical expression for that. Please substitute the value and let me know the value of delta V. So what is the mathematical expression? Change in position, mass into change in velocity, which is equal to h by 4 pi. So what is delta V then? H by 4 pi into 1 by delta H into 1 by mass. That's it. So just substitute all those values and simplify, and please come up with the value of delta V. So the value of Planck's constant is 6.626 into 10 to the power of minus 34 kilogram meter square second power minus 1 divided by 4 into value of pi is 3.14, and uncertainty in position is given as 0.1 angstrom. So 0.1 can be written as 10 power minus 1 and angstrom can be written as 10 power minus 10 meter. And what is the mass? Which is 9.1 into 10 power minus 31 kilogram. So this kilogram and kilogram will get cancelled out. 1 meter and this 1 meter will get cancelled out. So we'll get the unit in meter per second. So 6.6 into minus 10 power minus 34 divided by 4 into 3.14 can be written as 3 and 9.1 can be written as 9, and simplify all those 10 powers and please come up with the value of delta V. Here the catch is 10 powers because in all the option the values are same, right? Divya, what was your final answer? So your answer is option C, right? What was the value? Tatvatika, what is your value for delta V? Okay, Tatvatika's answer is 0.055 into 10 power 7. Okay. How about Divya? What is your answer for delta V? Tatvatika, the answer is not option 2. Um, Divya, okay, Tatvatika, please check. So first you simplify all those 10 powers, and after that you calculate all those numbers and please come up with the value. .6 divided by 12 into 9 into 10 power minus 34. This is 10 power minus 42 meter per second. Varshini, what is your answer? Geetan? So by calculating, we'll get 5.79 into 10 power 6 meter per second. Okay. Okay, Geetan's answer is 0.06 11 into 10 power 8. Okay. So approximately we can write it as 6.11 into 10 power 6. Right. So approximately answer is option 2. Option 4. Right. Okay, Geetan. Right. Very good, Tatvatika. Okay, Kana. Okay, super. So finally, Tatvatika came out to the right answer. Very good. Very good, Geetan. Okay, we'll move on to next question. Uh, Divya, you got the answer right? Divya?
Yes, ma'am.
Okay. So we'll move on to next question. If uncertainty in velocity and position is same, then the uncertainty in momentum will be dash. Uncertainty in velocity and uncertainty in position are same, then what is the expression for uncertainty in momentum? Again, the question is from Heisenberg's uncertainty principle, right? Okay, Tatvatika's answer is option C. Roshini, Tony, Varshini. Kalai. Geetan, what is your answer? Okay, let us derive here. So basically, we know that delta x into mass into delta v, which is equal to h by 4 pi. This is the mathematical expression of Heisenberg's uncertainty principle. And what is the condition here? Delta V is equal to delta X. So in place of this delta X, I'm going to substitute it as delta V. So delta V into mass into delta V, which is equal to h by 4 pi. Now we have to come up with the expression for change in momentum, right? So what is change in momentum? Which is mass into delta V. So here I have mass into delta V. Instead of this, I can write it as delta P. But here I have one more delta V, right? But in option we don't have delta V at all. So what I'm going to do is left side and right side I'm going to multiply it with m. So mass into delta V into mass into delta V, which is equal to mass into h by 4 pi. So this is delta P and this is also delta P, which can be written as delta P square, which is equal to mh by 4 pi, or delta P is equal to root of mh by 4 pi. So which is option A. Is that clear? Is that clear? Okay. Divya's answer and Geetan's answer was right. Okay. Okay, Varshini, fine. Okay, Kana, fine. We'll move on to next question. Okay. Here, let nu1 be the frequency of the series limit of the Lyman series, nu2 be the frequency of the first line of Lyman series, and nu3 be the frequency of the series limit of the Balmer series. And they're asking us to find the relationship between nu1, nu2, and nu3. So this question is from hydrogen spectrum. So find the relationship between all the three frequencies. So in hydrogen spectrum, we'll be using only one formula, which is 1 by lambda, which is equal to Rydberg constant into Z square into 1 by N1 square minus 1 by N2 square. But here they're asking us to calculate the frequency. So this 1 by lambda should be written in terms of frequency. How to convert 1 by lambda into frequency? Basically, nu is equal to C by lambda, right? So 1 by lambda can be multiplied with C to get frequency, right? So left side and right side, I'm going to multiply it with frequency of light. So C by lambda, which is equal to C into Rydberg constant into atomic number into 1 by N1 square by minus 1 by N2 square. So this can be written as frequency. So frequency is equal to velocity of light Rydberg constant Z square into 1 by N1 square minus 1 by N2 square. So this is the formula which we're going to use in this problem. So first you have to calculate nu1. What is nu1? It is the frequency of the series limit. What is the series limit of Lyman series? They are talking about the last transition in Lyman series. Okay. What is Lyman series? If the electron is in the excited state, electron will be coming from excited state to the first state, right? In this transition, which will be the last transition, infinity to first state, right? So here the value of n2 is infinity and the value of n1 is 1. So C into Rydberg constant into, since we are talking about, okay, they didn't mention any atom here. So I'm writing it as Z square into 1 by n1's values 1 square minus n2's value is infinity, right? So what is nu 1? Nu 1 is equal to C into Rydberg constant into Z square into 1. That's it. So this is equation 1. So similarly, I'm going to calculate the value of second frequency. So C into Rydberg constant into Z square into 1 by frequency, that is it, nu 2 is nothing but the frequency of first line of Lyman series. What is the first line of Lyman series? Electron will be coming from the second state to first state, right? This is the first line of Lyman series. So what is the value of n1? 1, so 1 square. And what is the value of n2? It is 2, so 2 square, 4. So nu 2 is equal to C into Rydberg constant into Z square into 1 minus 1 by 4, which is 3 by 4. This is equation 2. And what is nu 3? Nu 3 is the frequency of the series limit of the Balmer series. So C into Rydberg constant into Z square into what is the value of n1 and what is the value of n2? Series limit of Balmer series is nothing but they are mentioning the last transition of Balmer series. So what is the last transition of Balmer series? Electron will be coming from infinity to second state, right? So the value of n1 is 2 square minus 1 by infinity. So 1 by infinity is 0. So nu bar is equal to, frequency is equal to C into Rydberg constant Z square into 1 by 4. That's it. So this is equation 3. Now you have to find the relationship between nu 1, nu 2 and nu 3. That's it. Find the relationship between nu 1, nu 2 and nu 3. See, if you add nu 2 and nu 3, we'll get nu 1. Add this nu 2 and nu 3. Nu 2 plus nu 3, which is nothing but C Rydberg constant Z square into 3 by 4 plus C Rydberg constant Z square into 1 by 4. In these two terms, C Rydberg constant Z square were common. So 3 by 4 plus 1 by 4, which is nothing but 4 by 4, it will get cancelled out. So what is nu 2 plus nu 3? Which is C into Rydberg constant into Z square, which is nothing but nu 1. So nu 2 plus nu 3, which is equal to nu 1. So which will be the right option then? If nu 1 is equal to nu 2 plus nu 3, then which will be the right option? Or this can also be written as, what is nu 3? Nu 3 is equal to nu 1 minus nu 2. So the answer is option A. Is that clear? Is that clear? Tony? Okay, Geetan. Roshni, is that clear, Kana? Tatvatika? Okay. We'll move on to next question. Which of the following is not a permissible arrangement of electrons in an atom? In each option, we are provided with a set of quantum numbers and we have to find which is not a permissible one. Very easy. Which is not a permissible one. So in first option, n is equal to 5. If the shell is fifth shell, in fifth shell we'll be having 5 subshells. L is equal to 0, 1, 2, 3 and 4. So L is equal to 3 is permissible one. So in L is equal to 3 subshell, we'll be having orbitals like -3 to +3 through 0, right? So M is equal to 0 is permissible. And in which electron will be there? It can be plus half or minus half. So this is a permissible one and this is not the answer. In second option, n is equal to 3. We are talking about third shell. In third shell, we'll be having 3 subshells. L is equal to 0, L is equal to 1, L is equal to 2. So in which L is equal to 2 is a permissible one. This is right. In L is equal to 2 subshell, we'll be having 5 orbitals. -2, -1, 0, +1 and +2. But here they have given the value as m is equal to -3, which is not the case here. So this is not the permissible arrangement. So the answer is option B. Is that clear? Is that clear? Fine. Next question. Compare the energies of two radiations, E1 with wavelength of 800 nanometer and E2 with a wavelength of 400 nanometer. So we have to find the relationship between E1 and E2. Find the relationship between E1 and E2. See, they are talking about two radiations, okay, whose energy is E1 and E2. So for this radiation, the wavelength is 800 nanometer. And for this radiation, the wavelength is 400 nanometer. What is the relationship which relates energy and wavelength? E is equal to hc by lambda, right? So for this, E1 is equal to hc by lambda. Here the lambda is 800 nanometer. And for second radiation, E2 is equal to hc divided by 400 nanometer. So to find the relationship between E1 and E2, I'm just going to divide these two quantities. So which is equal to hc divided by 800 nanometer divided by hc into 400 nanometer. I'm going to take reciprocal of that. So 400 nanometer divided by hc. So hc will get cancelled. This and this will get cancelled. So this is 2. So E1 by E2, which is equal to 1 by 2. or 2 times of E1, which is equal to E2. So the answer is option C. Right? Do you have any doubt? Geetan, is that clear? Okay. Right. Next question. Choose the correct statement for the light wave whose period is 2 into 10 power minus 10 seconds. See, they have given you the value of time period t. And first statement is frequency of the light wave is 5 into 10 power 9 hertz. Second statement is wavelength of this light is 6 into 10 power minus 2 meter. And third statement is wave number of the light is 16.66 meter inverse. Option D, all of these were true. So from time period, we can calculate frequency, right? What is the relationship between frequency and the time period? Frequency is equal to reciprocal of time period, right? So time period is given as 2 into 10 power minus 10 meter. So 1 by 2 into 10 power minus 10 seconds. So 1 by 2 is nothing but 0.5. 10 power minus 10 will come to the numerator. So 10 power plus 10 seconds will come to the numerator. So second inverse. So this can be written as 5 into 10 power 9 second inverse. Second inverse can be expressed as hertz. So for this light wave, if the time period is 2 into 10 power minus 10 seconds, then its frequency will be 5 into 10 power 9 hertz. So this statement is true. Now we have to check for the wavelength. So what is the wavelength? Lambda is equal to, or nu is equal to C by lambda, or lambda is equal to C by nu. So what is the value of C? 3 into 10 power 8 meter per second. And what is the frequency? We have calculated it, right? So 5 into 10 power 9. Hertz can be written as second inverse. So the second inverse and the second inverse will get cancelled out. So please simplify and tell me this. So this 3 can be written as 30 into 10 power 7 divided by 5. 10 power 9, I'm going to take it to the numerator, 10 power minus 9. So what is the value? So 30 by 5 is 6. 10 power minus 2 meter. So second option is also right. So what will be the answer then? What will be the answer? Option 4, right? So this is the right answer. So we'll move on to next question. If you want to, you can calculate the wave number also. What is wave number? Nu bar. Nu bar is nothing but reciprocal of wavelength. So you have calculated the value of wavelength, substitute the value of lambda and simplify. You'll get the value of wave number also. So next question. The electron identified by quantum numbers n and l are given. You have to arrange these electrons in the increasing order of energy. Very easy question. Have to calculate which orbital got lower energy and other got higher energy. That is a rule, right? What is the rule? N plus L rule. So calculate the value of N plus L for all the orbitals, and the orbital with less N plus L value will have lesser energy. If two orbitals got same n plus L value, then check for the principal quantum number. The electron with less principal quantum number will have lesser energy. That's it. So arrange these in the increasing order of energy. So here the n plus L values 4 plus 1 is 5. Here 3 plus 2 is also 5. Here 4 plus 0 is 4. 3 plus 1 is 4. So among A, B, C, D, B and D must have lesser energy because these two orbitals got lesser n plus n value. But among B and D, which will have lower energy? D, because this got less principal quantum number, which is 3. So lesser energy is D, after which B, after which among A and C, which got lower energy? C and A. So the answer is option C. Is that clear? Fine. Next question. A particular station of All India Radio New Delhi broadcast on a frequency of 1368 kilohertz. The wavelength of the electromagnetic radiation emitted by the transmitter is dash. So they have given you the frequency and they're asking us to calculate the wavelength. So the formula is nu is equal to C by lambda. What is lambda? C by nu. So what is C? 3 into 10 power 8 meter per second. And what is the frequency? 1368. And what is kilo? Kilo can be written as 10 power 3. And what is hertz? Hertz can be written as second inverse. So this second inverse and this second inverse will get cancelled out. And please divide these two numbers and please tell me the value of lambda. Guys, while dividing, you have to be very careful because check for the option A and D. Both were nearly same. So you have to divide exactly. We cannot take any approximations. Whenever your options are very narrow, please make sure you're not rounding off anything. Okay, you should not take any approximations. So this 3 into 10 power 8 can be written as 3000 into 10 power 5 meter divided by 1368 into 10 power 3. So this 10 power 3, I can take it to the numerator. So into 10 power minus 3. So 3000 divided by 1368. So what is the answer? Yes, answer is option D. Okay, option D. So shall we move on to next question? Guys, shall we move on to next question?
Here, madam, I just wanted to tell one thing to our students. The answers are
Yes,
very,
sir.
very close, 219.2 and 219.3. So you cannot make any approximation here. Am I correct, madam?
Yes, sir. Yes.
So when if the answers are not very close, you can do some approximation and then find the answer. But if they're very close, then you have to, 3000 divided by 1368, you have to divide. There's no other go. Till the last thing, you have to decide and find out what is the exact answer. So that these are something which you should keep in your mind. No, when you look at these things, no, immediately when I saw the options, it runs into my mind. So this is the problem where I have to calculate till the last stage. So things like that should go in your mind. So anyway, thank you, madam.
Okay, sir. Okay. So shall we move on to next question?
Are you tired, or should we go to next question? Only one person is raising the hand. Okay, I think you can go for one more question, madam. Two, three are they are ready.
Okay, okay, sir. Okay. So the next question is we have to identify the incorrect statement. So identify the incorrect statement from the following. So the first statement is the shapes of dxy, dyz and dz orbitals are similar to each other, and dx square minus y square and dz square are similar to each other. Whether the statement is right? Is that right? What is the shape of dxy, yz and dzx? This is x-axis and this is y-axis. What is the shape of d orbital? Double dumbbell, right? So I'm going to draw the shape of dxy. So electron density will be in between x-axis and y-axis. This is x-axis and this is, let us take this as z-axis. Now the electron density will be between x-axis and z-axis. So this is the shape of dzx. And next, this is y-axis and this is z-axis. So the electron density is between z and y. This is the shape of d, y, z. So these three orbitals have same shape. There is no doubt about it. But what is the shape of the x square minus y square? This is also double dumbbell, right? So this is x-axis and this is y-axis. Now the electron density is on x-axis and y-axis. And what is the shape of dz square? Let us take this is z-axis and the shape of dz square is dumbbell shape with one donut shape, right? So among these five orbitals, dxy, yz, zx, x square minus y square, all these four orbitals will have same shape, right? But here the statement is the shapes of dxy, yz, zx orbitals are similar to each other, and dx square minus y square and dz squares are similar to each other. Obviously, the statement is false. You guys got my point? Okay. And how about second option? All the 5d orbitals are different in size when compared to the respective 4d orbitals. Definitely, because here the principal quantum number is 4. Here the principal quantum number is 5. So, since this is higher energy, the size of 5d orbitals will be greater than 4d orbital. So, this statement is right. And in third option, all the 4d orbitals have similar shapes to the respective 3d orbitals. This is also true. In an atom, all the 5 3d orbitals are of equal energy. Obviously, in 3d subshell, all the 5 orbitals are in degenerate state. So fourth statement is also true. So the answer is option A. Is that clear? Is that clear? Shall we move on to next question?
They may be very
Actually, this is
tired,
neat
ma'am.
question.
They may be tired. No, already 8:50.
Okay, sir. Okay. Then we'll wind up the
Yeah,
session,
we will
sir.
wind up. Then
Okay. Okay, guys, okay.
Please
My
speak out. No, if you don't